let's solve some theory and then the numericals. Law of diminishing returns. What do you mean by law of diminishing returns? See, it means that as you go on increasing the sample size, you become more accurate. See, suppose if you take, see, give you this example. The population is 1000. Pay attention, everyone. Population is 1000. Suppose if the sample, okay, this sample, I take 20 sample or I take second case 200 sample. Pay attention. Okay. So I take 20 sample or I take 200 sample. In that case, what was this Subramaniam? Have you joined ABM full material? No, it is not there. ABM I'm having it. Let me see. I've got it or not. Yesterday I was planning to give you, but yesterday up till now, I had not got it. Let me see. Give me 1 minute. Huh? Because it's a big file, it doesn't get uploaded. Hold on. Yeah, I got it. One second, I'll give you. One second, let me see if it is complete or not. Yeah, it is full. Take this. Who wants it? See this, everyone. ABM full PDF. Okay, ABM full PDF. Take it. That also I had not given. No, take this. ABM full PDF. See, this is the one. This is a full PDF. Includes everything, all your ABM. In this also, kindly read only, pay attention. Kindly read only the theory part. Okay? Only read the theory part. Numericals, I am taking it over here. So kindly read the theory part over here. Numericals, I will be taking over here. Okay? Read complete theory part. Everything is given over here. All of the things are there. It includes other modules also. Kindly note, module B and D is also included in this. Okay, which I am not teaching. That is also there. Module B and D is also there, which I am not taking. Okay, so it includes everything. Got it, everyone? See, I'll share it in the pin comment. Pin comment I am sharing. Okay, I have shared it in the pin comment. Everyone get this. Okay. Chalo, let's move on. So suppose if imagine I am taking 20 samples or 200 samples. There are two cases. In one case I am taking 20 samples, other case I am taking 200 samples. So now you tell me who will be more accurate? Accurate will be 200 samples, right? So 20 samples will be less accurate, 200 samples will be more accurate, isn't it? Now, where will be the error more? Where the error will be more? 20 samples, error will be more. 200 samples, error will be less. Right? What is the cost? For taking 20 samples, cost will be less. For taking 200 samples, cost will be more. Isn't it? Got this point? So, kindly understand. Law of diminishing returns means as you go on increasing the samples, your accuracy increases, but your cost also increases. See, less, more, less, more. So your accuracy increases and your cost also increases. Okay? Now, if after doing all these things, You increase the sample to 200 from to 20. And now what happens? You find a difference in the answer. For 20, the answer is 1.1. For 200, the answer is 1.12. So what is the difference? 0.02 difference. So is it worth doing this? See, the increased precision may not worth the cost. So if I'm increasing to 200 samples and then not getting better answer, then why should I increase? I'll do it with 20 only, isn't it? The increased precision may not worth the cost because n is in the denominator. When we increase it, the standard error decreases. Standard error decreases as you go on increasing the sample size. Whether to take 200 samples or to take 50 samples in a population of 500. Surveying 200 would require more cost than surveying 50, isn't it? And if it's not adding the value, then take only 50. Okay? Got it? Got this point? This question is asked in exam. Law of diminishing returns. Two, three theorems are asked to you in exam now. Okay? One is law of diminishing returns. Second one is also there. That I'll show you. Sampling from non-normal population. Now this already we have covered. Let the population be normal. Sampling distribution will always be normal. Yesterday also I covered this. So the population be normal or not normal, sampling distribution will always be normal. Central limit theorem. Okay. Now this is also asked in the exam. Almost every exam it is asked. Central limit theorem. As the sample size increases, the sampling distribution of the mean will approach normality regardless of the shape of the population distribution. So, as you go on increasing the sample size, the sampling distribution will become more and more normal. Normal means what? What do you mean by this word normal? Normal means this. See this. Suppose if I am having the sample of 20, see this sample of 20, okay? Then some samples will be over here. There will be more error. All of them will not be within this curve. If I increase the sample to 200, so almost all of them will come under this curve. This is called a normal distribution curve. So this is called as normalization. Okay. As you go on increasing the sample size, all these samples come within this curve and it becomes a normal population, normal sample. Okay. See, the sampling distribution of the mean will approach normality regardless of the shape of the population. So whether this population is like this or it is normal or not normal, anything. But the sampling distribution will always tend to be normal as we go on increasing the sample size. It states that sampling distribution of a mean approaches normal as the sample size increases. Statisticians use normal distribution as an approximation to sampling distribution when the sample size is at least 30. Now, this is the exam question. This is always the exam question. When will you use the central limit theorem? You will use it when at least you have 30 samples. When you have at least 30 samples, only then it is used. Otherwise, it is not used. What is the use of central limit theorem? The use is same. You do anything on sample and then apply it to the population. It permits us to use the sample statistics to make the inference about the population. So it's like, see, sample, I'll give you one example. Suppose if you want to taste, means whether the tea is hot or cold. You want to check whether the tea is hot or cold. Do you drink the whole cup of tea or do you take just one sip? Do you drink the whole cup of tea or do you take one sip? Of course, you will take one sip and from that you will know whether the tea is hot or cold. Isn't it? Same logic applies over here. I want to do the survey of the population, but do I go to all these houses It's not worth. Cost, huge cost is included. So what will I do? I'll take some samples and then do the survey of those samples. And then I'll say that, oh, whole population is like this. Okay? So use of central limit theorem, it permits us to do the survey or anything on the samples and apply the inferences to the population without knowing the population actually. You are not knowing the population at all. Okay? Now this question is asked in exam. This is a probability question. See, if X is binary, now this binary means binomial we call it. This is a part of your probability distribution, but it is given in this chapter also. Then Z means what? Z is a table that I'll show you now. Z equals to X minus NP upon root NPQ tends to be normal to standard normal deviation as n tends to infinity. Standard normal, kindly note. See, both the meanings are same. That as you go on increasing the sample size, it becomes normal. Second one, x is equals to p lambda. This is Poisson. This Poisson distribution, you will see it again in probability chapter. There I'll take it in more details. Right now, don't go into it. Right now, you only understand let anything be binomial or Poisson. As you go on increasing the sample size, it will become more normal, tends to be normal. In exam, what do they ask you? In exam, they ask you these two formulae. For binomial, you have to remember this is a formula. For Poisson, you have to remember this is a formula. Poisson always has lambda. Binomial does not have lambda. This is a hint. Means they'll ask you if it is a binomial distribution, then z equals to this much. They'll ask you. So you must know binomial does not include lambda. Then you'll take this one. If you don't know this, you'll take anything. Okay. So binomial doesn't have lambda. Poisson has lambda. Okay. Relationship between sample size and standard error. Now, this is also simple. As you go on increasing the sample size, the error will decrease. That's what is given. As the standard error decreases, the value of any sample mean will probably be closer to the value of the population mean. So, as the standard, see what is standard error basically? Standard error is the difference, right? Standard error is, I told you yesterday or yesterday only, yeah, that it is the difference between the population mean and the sample mean. Okay, let's see this. Suppose if I show you this, then standard error means what? Standard error means this is known as the population mean, population mean. Okay, this is called as mu, and then you have this is another. This is known as sample mean. Okay, and the difference between them is known as standard error. Okay, so this is the meaning. Got it? So same thing is mentioned over here. As your standard error decreases, the sample mean and population mean will be same. This is what is given. The value of any sample mean will probably be closer to that of the population mean. Okay? And second line is not that important. First line is important, which is asked in the exam. Okay? Only first line is asked. Parametric statistics. Now understand simple word again. Parameter relates to population. Statistic relates to your sample. Okay. So parametric statistics are based on the assumptions about the distribution of population from which the sample is taken. So wherever you hear the word parameter, remember it, we are talking of population. Non-parametric statistics are not based on assumptions. That is, the data can be collected from a sample. that does not follow specific distribution. So, parametric will be population, non-parametric, or you can call it statistical. Okay, so that will be based on sample. Remember these words perfectly. Okay, yes, Vishal, correct. Standard error equals to standard deviation upon the root of n. This is for infinite population. For finite, it is upon root of n into root of n minus n upon n minus 1. Okay, that is for infinite population. Okay, now see this. This is what I was going to show you. See this. Infinite and finite population. Infinite population is psi upon root of n. Psi means standard error. N is sample size. This is for infinite. For finite, it is same, but just multiplied with finite population multiplier. Root of n minus n upon n minus 1. Always remember, whenever you are dealing with finite population, you must, what is finite? Finite means countable, which can be counted. Infinite means which cannot be counted. There are five formulae for standard error. Kindly note, there are five formulae. Okay? Five. So, all of them you are having it. Huh? See, first is this. Which are the five? Chalo, let me show you. First is this, infinite. Second is finite. Okay. Third one is in probability. In probability, you have another formula. Fourth one is in correlation and regression. And fifth one is in estimation. So these are the five formulae. Now, what do you do with the standard error? Once you get the standard error, what you do is you use this standard error to find out Z. Now, what is Z? Z means, see, just now I showed you this Z, this Z. Z is a table. Now, what is this table? Let me show you that table also. This is the table. This is called as a normal distribution table. Normal distribution table. This table, the values over here are known as probability. See, always this normal distribution table has two parts. One is, see, this is known as probability. I'll show you over here. Where do I show you? Here only. See this. These values are known as Z. See, this and this. This is known as Z. And this inside part is known as probability. This inside part is known as, so all these values are probability, and these above, top one and left one is known as Z. Okay. So your target is finding this Z value, this Z. Once you find this Z value, then you can find the probability also. So that we'll be doing it today. Our target for today is this only. Okay. So kindly understand what are we doing. Our target in sampling distribution problem is find standard error, then find Z, then find probability. This is our target. Standard error, then Z, then probability. How to find out Z? The formula for Z is this. X bar minus mu upon psi x bar, or standard error. X bar minus mu upon psi x bar, standard error. Okay. See, in anything, any statistic, you have these important parts. Capital N population, small n sample. Standard error is no standard deviation for population, standard error for sample. Population mean is called as mu, sample mean is called as x bar. Now let's solve the numerical. One numerical we'll solve. Population is given as 1000. Sample is given as 100. Mean is given as 6. Standard deviation is given as 12. Okay. And sample mean is given as 7. So everything is given. You have to find out the probability. So first find out the standard error. Now tell me, this is finite population or infinite population? 1000 people, sample is 100. So is this finite population or is this infinite population? Yes, is this finite population or infinite population? It is finite population. Why? Because you know it is 1000 people. Population, when you know the population size, it's called as finite. So now which formula will you apply? You will apply the second formula, not the first one. So find out the standard error. Standard error is what? Psi upon root of n into root of n minus n upon n minus 1. So what is psi? Psi is given as standard deviation 12 upon root of n. N is what? Small n. Focus. It is small n. Okay. So small n means this psi upon root of n. This is psi is given as 12 and n is given as 100. Small n. So 12 upon 10 because root of 100. So 1.2. See this, you have got it 1.2. So 1.2 into root of n minus n. 1000 minus 100 upon 1000 minus 1. Isn't it? 1000 minus 100 upon 1000 minus 1. So this is known as your standard error. So you'll get this 1.2 into root of 900 upon 999. So do the calculations, you'll get it 1.13. So standard error, you are getting it as 1.13. You will get 1 mark numerical on finding the standard error only. One is for infinite, second is for finite. So this is known as the standard error. Suppose if in exam they don't give you 1000 people, they don't give you this. Then this becomes infinite population because you don't know the final population then. Okay? Then you will use the formula only psi upon root of n. Got it? Now you have found out standard error. Now find out z. What is z? See this, z equals to 1 upon standard error into x bar minus mu. So 1 upon 1.13 into x bar is what? 7. Minus mu. What is this population means 6. 7 minus 6. So 1 upon 1.13. So do it. 0.88. So z equals to 0.88. Okay. Z equals to 0.88. Got it? Now if they ask you sampling fraction. So what is sampling fraction? Sample upon population. So 100 upon 1000. So it is 0.1. What did we see yesterday? Whenever sampling fraction is greater than 0.05, then only you can do the calculations. Otherwise, these calculations have no meaning. If the sampling fraction is greater than 0.05, then only you can apply this formula. Otherwise, you can't apply the formula. So first you will have to check sampling fraction always. Okay? And then only you can go. Now suppose one question will arise in your mind. Suppose in the exam, they don't give you 1000. They'll give you only 100. And then sampling fraction is asked. Then what? Then there's no sampling fraction. It can't be answered. Why? Because for finding the sampling fraction, you require the population also and sample also. Okay? So, if population is not given, then you cannot have sampling fraction. So, for infinite population, you can never have a sampling fraction. For infinite population, you can never have a sampling fraction. Okay? For finite, you can have. So, kindly note the sampling fraction they ask you for 1 mark. What is sampling fraction? Or they ask you to find out. So, it's very simple. Sample size upon population size. So, now you have got it Z. Now, look at it. See, you have got it Z over here. Now, what to do with this Z? We have to find out the probability. How to find out the probability? See this. What was Z? 0.88. So what you do? 0.88. How will you do? What will you do about 0.88? See, you divide this into two parts. Okay. How will you divide this? See, like this. First, lower part is known as 0.8. First is you will search over here, this two parts like this. Okay. So what will you do? One second. We will divide this into two parts. This you will search down. This you will search horizontal. So first search zero point 0.8. Check this. First search zero point 0.8. Zero point 0.8. Look at this. 0.1 to the this is zero point 0.8. Second search this 8. This 8 will be over here. Search this 8. Now combine them. This 8 and this zero point 0.8. Combine them. Where do they meet? Check this. Zero point 0.8 and 8. They will meet over here. 0.3106. Are you seeing this? 0.3106. Everyone is seeing this? Zero point 0.8 over here and 8 over here. When you combine them, you'll meet it, they'll meet over here. 0.3106. Got it? Clear? So now this 0.3106 is known as the probability. This is the probability. So how to find out the probability? Kindly note, you have to divide this into two parts, Z into two parts. One, you have to, first part you have to search vertically, second part you have to search horizontally. Now suppose if you get this Z as 1.66, so how will you search? Again divide it into two parts, 1.6 separate and 6 is separate. So you will search 1.66, suppose if I give you, how will you search 1.6 first? See 1.6 over here. And then you will search 6. Where is 6? This. These two you will combine. So it will be 0.4515. Okay? Suppose if I give you, everyone now give me the answer for 0.27. Give me the answer for 0.27. Everyone. Give me the answer for 0.27. 0.27. So it is correct. 0.1064. It is 0.1064. Correct? Got it? 0.27 is 0.1064. Clear? This is how you have to do it. 1064 or 67, whatever. 64, I think so. Let it be anything. Now this is a big question, Ravindra. This is a big question. See, in exam, whether they will give you this table. This is very big question. Up till now, they have not given this table. Up till now, they have not given this table. Okay. So then what happens? You'll say, how will we find out the probability then? So they will not ask you for probability then. In exam, up till now, they have asked only for finding standard error and Z. Only that much. Standard error and Z. No probability. Because for finding the probability, they have to give you the table. But they don't give you the table. So they ask you only up to Z. Okay? But if your luck is difficult or if you have a hard luck, they will give you the table also. Because table is not that difficult. They can give you the table in the paper also. So if they give you the table, then you'll have to find out the probability. Okay? Now, suppose if I ask you the question, okay? Let's see something. Huh. Let's see this. A bank calculates that its individual savings account are normally distributed with a mean of 2000 and standard deviation of 600. Okay? So mean is 2000. Mean means what? This is population mean, mu. Standard deviation of 600. So this is psi 600. If the bank takes a random sample of 100, so 100 is what now? Small n. Kindly note, it is not capital N. What is the probability that the sample mean will lie between 1900 and 2050? So now there are two questions. One is for 1900, second is 2050. Now population mean is given as what? 2000. So first you have to draw this normal distribution curve. Now when you draw this curve, first this center is known as population mean 2000. So here I'll write 2000. Okay, this is 2000. Now what is one? One is 1900 sample. Now this is sample mean. So sample mean one is 1900, second is 2050. So now look at it. This is 2000. So 1900 will be where? Right side or left side? It is always left side because left side is small, right side is big. So 1900 over here, and over here you will be having this 2050. So now they are asking you to find out the probability. Now this dotted part you have to find out. This full dotted part. Okay. Now how will you find this? You have to solve two problems. One problem is this, second problem is this, and then you'll have to add them. Okay. One is this, second is this, and then you'll have to add them. Right? So now let's find out. First one. First. First find out the standard error. Now you tell me. This is infinite population or finite population? Everyone. This is infinite population or finite population? Correct. It is infinite. Why? Because you don't know the population size. It is infinite. Correct? Because this 100 is sample. So now what will you be using? So infinite means formula is simple. Psi upon root of n. So what is psi? Standard deviation 600 upon root of n, root of 100, 10. So 600 upon 10, 60. Standard error you got it 60. Okay. Now you have to find out 2z, 1z and z2. One is for this, one is for this. So find out the z. So z over here will be, what is this z? Look at this. This z will be 1 upon standard error, 1 upon 60 into x bar minus mu. What is x bar? X bar is 1900. What is required? X bar is required. So 1900 minus population mean 2000. So 1900 minus 2000. So that is what? Something 100, I think so. Yeah, 100. 100 upon 60. So 1.66. Pay attention, everyone. Slowly, slowly pay attention. So Z is 1.66. Ignore the sign. Leave that sign. Sign is of no importance. So now 1.66. Stop over here. So Z1 you got it 1.66. Now Z2. 1 upon 16 to 2050 minus 2000. Right? So 50 upon 60. So 0.83. So Z2 you got it now. Z1 got, Z2 got. Now what next? Probability. How will you find out the probability now? Go to the table. First one was what? 1.66, isn't it? 1.66. See 1.6 over here. 1.6 over here. See this. 1.6 over here. And then 6 over here. So do it. It is. Can anyone get me this? What is the answer for this? 1.66 I want it now. 1.66 I want it. What is the answer for this? 0.4515. Very good. This is 0.4515. So this is your probability for first one, 0.451515, not 25. Okay, 0.4515. So this is your probability for 1900. Okay. Now second one. Second one is what? What is second one? Second one A over here is, which is the second one asked? 0.83, I think so. Isn't it? 0.83. Two are there, no? See, the second one was 0.83. Correct? So now 0.83. What is it for 0.83? Now you give me the answer for 0.83. Let me see how many of you can get this. 0.83. What are you getting? Correct. 0.2967. Okay, see this. The answer over here is 0.2967 on this side and 0.4515 on this side. Right? But what is asked? See, this is 1900, this is 2050. What is asked? Lying between 1900 and 2050. So you require the total. So total is both addition 0.4515 plus 0.2967. So your answer will be something, add them. What are you getting? Check this. If you add them, 0.7482. This is your answer. So your probability is 0.7482, or in percentage it is 74.82. 74.82. Got it? Clear everyone? Now, now see, I won't leave it immediately. Now I'll ask you one important question. Pay attention, everyone. I'll give you the same problem now, okay? And you will have to give me the probability of. Let me bring in a fresh slide now. Hold on. Hmm. Yeah. So now let me ask you one question. Now I want the probability of lying between 2050 and 2200. I want this probability. Okay, lying between 2050 and 2200. Okay, now you give me the answer. 2050 and 2200. Now you do all the calculations. Let me see. First, find out standard error. So let's do it. Let's solve it. Chalo. First, find out standard error. Error. What is standard error? 2050 minus 2000, right? 2050 minus 2000. What is the population mean? How will you do this? See, first, standard error formula is what? Psi upon root of n. I think so that is same. Psi is standard error, standard deviation upon root of n. So that is same. Standard error is same. That won't change. Let it be anything. 60, right? So standard error is same. 60. First, find out now Z. Z. What is the formula for Z? Z equals to 1 upon 60 into, now what, x bar minus mu. So 50 minus 2000, 2050 minus 2000. So 50 upon 60. So that is 0.83. This is for 1. Okay. This is for 2050. Now second, this is for 1. Now second, Z, 2200. 1 upon 16 to 2200 minus 2000. So 200 upon 2000. So it is 200 upon 60. So what is the answer? 1 point what? 3? 3? I think so. 200 upon 60. 1.33. Are you getting this? Everyone? Are you getting this everyone? 1.33